So, trigonometric ratios in right triangles. We already addressed this a little bit when we did our unit circle stuff last night. Okay, so we are going to be talking about all 6 trig functions. Now, the program that I use to print out these problems, unfortunately, it will not give me a question that says find all 6. It automatically puts like sine or cosine there, right there. So ignore this and read the directions. Follow what the directions say, because that's what I'm able to specify. I do want all 6 trig functions, okay? Hang on just a minute. Let me catch that for attendance. Oh, okay. We're good. Okay, so let's refresh our memory. We have sine, and instead of doing y and 1 over y like we did with the unit circle, we need to think of sine as opposite over hypotenuse, right? When we're in a triangle, that's what we're going to think of. What is the reciprocal of sine? A lot of people got this wrong on the warm-up. Cosecant. So if cosecant is the reciprocal, it's going to be hypotenuse over opposite. Does that make sense? And then if we have cosine is adjacent over hypotenuse, the reciprocal of cosine is secant, and that's going to be, I should put equal signs here, hypotenuse over adjacent. You follow so far? Pretty easy. And then finally we have tangent, which is opposite over adjacent, and therefore cotangent will be adjacent over opposite. So back to our good old SOHCAHTOA fun. Okay, we good so far? All right, so first thing I notice about this triangle, well, first off, here's theta, so that's good to know. But I notice I only have 2 sides. How am I going to find the third side? Because I'm going to need the third side to get all this stuff. I need to do Pythagorean theorem. What side is C? It's the hypotenuse, which is going to be 10, right? So 8 squared, we'll call this b squared. You can call it whatever the heck you want to. Equals 10 squared. 64 plus b squared equals 100. So I get a b value of 6. Everyone okay with that? Okay. So now, sine of theta is equal to opposite over hypotenuse, right? If this is theta, what's opposite? 6 over hypotenuse, which is 10. That can be reduced. So that would be my sine value. Okay? The reciprocal of sine is cosecant. Now, should I flip the 10 over the 6 or the 5 over the 3? Which one should I do? It doesn't matter, but if you flip this one and make it 10 over 6, you're still going to have to reduce it, and it's going to become 5 over 3 anyways, right? So let's just go right there. So sine theta is 3/5, cosecant is 5/3. What is cosine theta? Adjacent over hypotenuse, so 8 over 10. That reduces to 4 over 5. And the reciprocal of cosine is secant theta, which will be 5 over 4. Any questions so far? Fantastic. So then we have tangent theta, which is opposite over adjacent. Yeah? So opposite is 6, adjacent is 8. And that simplifies to 3/4. So what is cotangent theta? 4 Pretty easy? Give me a thumbs up if it's easy. Good. All right, number 2, I intentionally made a little more tricky. What do I need to do first? I need to find that other side, right? So 19 squared plus b squared equals 21 squared. Let me get my calculator going here. 19 squared is 361 plus b squared equals, what is 21 squared? Whoop. Ah! Seriously? There we go. 441. So b squared equals 80. That's not going to be a nice number, is it? When I square root that. So what I need to do is I need to simplify that radical. So if I think about 80 and I draw my tree, I have 40 and 2, 20 and 2, 10 and 2, however you choose to break this down, and 5 and 2. And what do I have? 2 and 2. I have 4 rad 5. You okay with that? Anyone need me to go slower on that reducing or simplifying part? So this side is 4 radical 5. So because there's a radical, that's going to cause a little bit of an issue as I'm setting up these ratios, because if I end up with a radical on the bottom, I do have to do some simplifying. So let's start off with sine theta is opposite over hypotenuse. Here's my theta. Opposite is 4 rad 5. Hypotenuse is 21. Can that reduce at all? Remember, I can reduce outside a radical with outside a radical, so I could look at the 4 and the 21, but it doesn't reduce. So that's just my sine value. The reciprocal of that one would be cosecant, and that's going to be 21 over 4 rad 5. Problem. Got to get that radical off the bottom. How do I do that? I can multiply by 4 rad 5 if I want to, but I can also just multiply by rad 5. That might make my life a little bit easier. Okay, so on the top I have 21 rad 5, and on the bottom I have 4 and then rad 25. What is rad 25? 5. 4 times 5 is 20, right? Because that becomes 5. And that can't simplify at all. So it's pretty ugly, but that's what it is. What about cosine theta? Adjacent over hypotenuse. Adjacent is 19. Hypotenuse is 21. That can't be reduced. No radicals. Yay. What's the reciprocal of cosine? Secant. So secant theta is going to be 21 over 19. No radicals to deal with cosine and secant. Tangent, I have a feeling the radical is going to come back in. So tangent theta, opposite over adjacent, that's 19. So it looks like cotangent is going to be the tricky one. So cotangent theta is going to be 19 over 4 rad 5. What do I multiply by?
Rad 5.
Rad 5 over rad 5. So that gives me 19 rad 5 over, now I already did 4 rad 5 times rad 5 up here. It ended up being 20, didn't it? Does that simplify at all? Nope. Okay. So I tried to give you an example of a clean one and a messier one. Okay. This is as bad as it would get right here. Not too bad? Okay. 3 and 4 are literally the exact same problems. I just don't give you a diagram. So it's important that you know how to make a diagram from the information I give you. Now, since I don't know who you all had from IM3, I don't know how well this was covered. Plus, I think it was on distance learning. But whenever you have a right triangle, okay, and we have to deal with right triangles when we're dealing with SOHCAHTOA stuff, the capital letters, I always draw my triangle the exact same way. Okay? The capital letters are representing the angles. Now, it doesn't matter which angle you label A or which angle you label B, but it does matter that the right angle is angle C. Okay? So label your C angle first, and then A and B, they're interchangeable. Doesn't matter. Okay? Angles are capital letters. What are the sides then? They are lowercase letters, and there is an order. Lowercase c is always going to be your hypotenuse because it's the side opposite C. Lowercase a is going to be the side opposite capital A. So whichever angle you labeled capital A, the side opposite there is lowercase a. And capital B, the side opposite there is going to be lowercase b. Does that make sense? That's always the way you set it up. C has to be the right angle. A and B, it doesn't matter, but once you set A and B, then the lowercase sides are the sides opposite the angle. Does that make sense? That's going to be really important when we get into the law of sines and the law of cosines. Okay? So, it says find the sine of capital A. So I'm going to call this theta, because that's the angle they want me to look at is A. If B is equal to 24, and little a is equal to 7. Do you see how I just filled in stuff there? So let's see. Sine I know is opposite over hypotenuse, right? I know opposite. Opposite is 7. I don't know the hypotenuse, though. How do I find the hypotenuse? Pythagorean theorem. 24 squared plus 7 squared equals c squared. 24 squared plus 7 squared. 625 equals c squared. And I think you can take a nice square root there. C is 25. So my hypotenuse is 25. So what is the sine of A? 7 over 25. Wasn't asking for all 6 there. Okay, questions about that one? I think I'm going to leave my little picture attached there so that I've got it. I'm going to leave that guy right there. Look at you. Perfect. Gotta love sticky notes. So I'm going to do a sticky note for this guy too. So here's my triangle. Okay. Again, label your right angle as capital C. The other angles, it doesn't matter, but just label one as A and one as B, both capital letters. Okay. Then you can fill in lowercase a as the side opposite capital A. Lowercase b is the side opposite capital B, and then lowercase c is opposite capital C. And that's where our Pythagorean theorem comes from too, which is why c squared is always the hypotenuse. All right, so find the sine of A if, again, sine is opposite over hypotenuse. If little b equals 4 and little a equals 16. Okay, I'm going to give you a minute to try that one. Okay. So same setup as before. So far, are you matching me here?
Yeah.
Okay, so I think I have 4 radical 17 as my hypotenuse. Okay, so when I do opposite over hypotenuse, again, they're finding sine of A. So that's the angle I'm looking at, calling it theta. Opposite is 16. And hypotenuse is 4 radical 17. Now, if that wasn't a radical, that would be my answer. But since it is a radical, I got to do my multiply by rad 17 over rad 17. And let's see what we get. Actually, you know what? Before I multiply, can I reduce 16 over 4? That becomes 4 and 1, doesn't it? That'll make things a little bit easier. So on the top, I have 4 radical 17. And what do I have on the bottom? 17. Because it's radical 17 squared. If I didn't do that reducing of 16 and 4 first, then when I get here, there would be something to reduce with the 4 and 17. So it doesn't matter if I do it first or second, as long as I do it before I box my answer. Okay? Questions on those two? Any questions? All right, we ready for the last two? Again, clean example, dirty example. We're going to do another clean one and another radical one. So I'm trying to cover both situations, okay? So find the cosine of theta if sine of theta is equal to 7 over 25. What do I know about sine? I know it is opposite over hypotenuse. And I know that cosine is adjacent over hypotenuse. So I know part of the answer. The hypotenuse is going to be 25. What I don't know is the adjacent. So could I draw a picture to go with this? Yeah. I don't have to, but I could. If I draw a picture to go with this, I know that the hypotenuse is 25, and I know that one of the sides is 7, but what I really need is the other side, right? Because that's what's going to be my numerator here. So let's say 7 squared plus b squared equals 25 squared. That's 49 plus b squared equals 625. So b squared equals 576. And b equals 24. So there's my 24. Has to be the adjacent side because that's the only one not represented there. So 24 goes right there, and that's my answer. By the way, this would be theta because opposite and hypotenuse, that's your sine values right there. Does that kind of make sense? Now, one thing I don't have here that I should have is I could say something like find cosecant if the cosine is this, right? Because it's still basically the same process, right? It's just setting up a different fraction to simplify, okay? So just know that you could be thrown in your cotangent, cosecant, and secant here also, okay? So why don't you take a minute and work through number 6 while I work through it also, and we'll see how we're doing along the way, okay? If it helps, draw a picture. Okay, let's see. Now keep in mind when you're squaring 4 rad 17, you have to square both the 4 and the 17. The easiest way is whatever calculator you're using, type it in parentheses. Oops, I don't need one there. But if you type it in parentheses like that, it will square both for you. Is that what you got for B? Or for the other side? Rad 17? So if I put rad 17 there, that's the opposite. So the sine of theta would be rad 17 over 17. Okay? A lot of SOHCAHTOA stuff, pretty much the difference between these is what information I give you and how to find the other information from there. Okay? Any questions at all? All right, I think we made it through our notes successfully, hopefully.